right away just so we could chat on it a little bit more. There's our kick out. So we may mention before about that 2-inch to roof. Okay, so here's my siding. We're using the EIFS as the counter flashing to the step flashing, and we want to see at least 2 inches of step flashing up in here. Now, if this wall continues on and the roof does not, for example, underneath this roof right here might be a garage, and then the house goes further on, so it stops. This styrofoam is about 1.5 inches minimum, all right, thickness that comes in there. So any water that's going to be running down this edge here, once I hit that styrofoam, I got 1.5 inches that I got to get that water away from there. So that's called a kick out, all right? And it's not done with the baby tin. They actually, you know, EMA or Synergy or Drive It, they actually make pieces for this purpose. And it's going to be, you know, if it was a 90-degree angle, it would go straight out, all right? So it has to be at least 110 degrees so that that water is going to want to shoot out towards the gutter. And it has to extend past the siding material by at least 1 inch, all right? I do want you to know both of those numbers. 1 inch past the siding and 100 degrees kick out, all right? We may mention earlier about the 2-inch clearance to the roof. Let's go back to our drawings here. This shows again with the back wrapping. Notice it's not the base coat that goes back there. It's only the fiberglass that gets back there. And that's again so we can protect the ends or the edges of the styrofoam as well. Where I have a butt seam up here, 2 pieces of styrofoam, those do not need to be back wrapped. So we just go right over it. It's only where the styrofoam terminates or stops. So openings such as openings such as windows and doors or the bottoms of walls, they need to be covered. All right. So here we have our sheeting. It needs to be something that's solid. Our foam insulation, and again, that's going to be our styrofoam. They're going to screw that in there and bolt it on there, typically behind the styrofoam. And this is the barrier system that we're looking at. Drainage systems are going to have a corrugated board behind there so that any water that gets in there, we give it a way out. We're going to use our fiberglass mesh, put it in our base coat, and then our finish coat, and that's basically it. Okay. We talked about that 1/2 inch clearance, all right? So this is our EIFS materials. And just to give you a clue, you know, up here on the right side coming down the corner, when you start seeing discolorations like that, and step back, you can even see how it's different from here to here. This is water, all right? So water is back behind this stuff. And like I said, once it gets back there, that's when it's problematic. This 1/2 inch, this is where we should be seeing it. So around this window, I'm actually comfortable with this. But around this door, I don't think they put any backer rod there. Now, of course, everything's going to be a guess. The only way for me to tell is to get up underneath the bottom of it. And sometimes you could stick your finger back in there and you could feel it. Or you could cut some of the sealant loose and then feel for that backer rod or get your camera underneath there and take a picture of it. That's about the only way you're going to be able to tell. All right. Let's slide forward again. Something else we didn't talk about. Well, before we go on to that, let's talk about this edge here. Remember I was showing on the 6 and 12 pitch up here? Same thing with this keystone. None of these are supposed to be flat. These are all supposed to be at least a 6/12 pitch when we come in there. Something else that wasn't on that list earlier is control joints. Right? One of the areas that we need control joints is wherever our structural lumber changes direction. So studs go up and down. Floor joists go horizontal. Studs go up and down. So right at this line here where you can see that bulge, we had our studs, we had our 2 top plates, we had our floor joists, we had our sole plate, and then we have more studs. Because we stacked, what was it? Let's not count the studs. 1, 2, 3, decking 4, sole 5, and stud 6. we stack 6 pieces of lumber, 6 different types. They're not always going to be perfectly right on top of each other. Sometimes there's going to be a gap that gets in there. But as time goes on with gravity, those 6 areas, those 5 openings, they're going to squish and compress. All right, it's normal. It's going to happen. So when that does, if I don't have a control joint in there, exactly what we're seeing here is what's going to happen, and it's going to end up buckling. All right, and that's going to be our problem. So we should, anytime we go from vertical to horizontal to vertical again, we want to have a control joint at that location. And obviously we don't. Doing true EIFS inspections is invasive. All right. You're going to be going around every door, every window. You're going to take readings from far away. Typically when you put in the reports, each side of a wall is going to be labeled, and then they're going to put it on a grid. They're going to use wet wall detectors and do scans from different areas in the flat surface. And then they're going to use these pinned meters. Protimeter makes them, and that's the name of a company, Protimeter, Protimeter. And that's those 9-inch probes, you just plug it in there. All right, that meter he has in his hand has both a surface moisture detector, and on that top cap there's 2 pins as well, and then you can plug in the 9-inch thing that he has, and it's able to be hit with a hammer, so you can bust through this stuff and get all the way in there. Now you want to get all the way to the substrate, and they're going to do the bottom left, bottom middle, and bottom right of the windows, and then they're going to do the top left and right above the windows, and same thing at the doors. They're going to do the top left and right at the doors, and the bottom left and right at the doors as well. So that's every door, every window that comes in there. And then they're going to use surface detectors to do the wall, spread out throughout the house. It's an all-day job. If this was and these are rather large homes typically, and these guys are getting close to $1,000, every time they go out there. And it's not a bad gig. You're going to be on site taking all your readings for maybe a half a day, and it's going to take you the other half of the day to write the report. So it actually pays pretty decent. And when they're done, they take sealant or caulk, and usually they buy a bunch of different colors that are identical to whatever the EIFS finished product is. They only have a limited number, so they just buy it from the EIFS manufacturers, and they'll go ahead and seal up those holes with the caulk and the sealant that comes in there. I've seen them do these tests, and when I used to do them, we would poke that thing in there and water would just squirt out. It was amazing. I would pull my probe and I'd see water leaking out. In milder cases, I would put my probe out and you could see the water detection on there. But that pin meter, this thing here, is also going to give me a number on it, and I'm able to document exactly what the moisture levels are. For us, 17 and 20 are our magic numbers. 17 is when we start getting into warnings, meaning we're getting water there somehow, whether it's condensation or air leakage. 20% is just too high, and that's we know we're going to start getting mold to grow. Whatever the case is, if it's under 17, usually we're okay. We like it to be closer to 10 or 15, but we don't always get that luxury. And then, of course, the higher it is, and typically if you got active water there, it's going to be 99 or 100% moisture. Right? So common problems we have: bulging, usually going to be the case of water entry or compression of structural materials. Cracking, that's going to have to do with expansion and shrinkage. Crumbling, we're too late, and we need to get repair work. If they put the wrong type of flashings in there, everything pretty much has to be metal flashings when you're dealing with either one of these materials. They're supposed to have a longer lifespan that comes in there, so we don't want to see any sort of plastic that comes in there. Obviously, if they lose some mechanical damage, that's common sense. Moisture entering is a problem. No drip screed, but that's only going to be on 3-coat stucco, not the 2-coat stucco. If you start seeing that metal lath rust pattern coming through the stucco, water's getting back there. All right, so that's going to be a problem. 8 inches is going to be our magic number for our close to the grade. Control joints, we want to see those on the eaves and change of directions and any type of change in material. When we're dealing with 3-coat stuccos, we want to see a lot of control joints. Those old Tudor homes that had the wood in between there, those were actually the control joints. All right, so that works as that, and that's fine. But the problem with that, using that as your control joint, well, it's water just collects to it and it causes it to rot. All right. I've seen a lot of high-end homes, especially in Lake Forest. We just did one recently. And they ended up redoing the entire stucco. It was over $100,000 worth of work. And, it was a wood frame home and there were no control joints on there. And I don't know what to tell my client. The installer put it on that way. And, as far as I'm concerned, it's probably not going to work. I'm going to give my client a heads up on that. But in all reality, what am I going to tell them to do? Well, put a saw on this area. I'm not going to do that. I'm just going to refer them back to the contractor and have them get it checked once a year. And improper clearances, 2 inches on the roof line, 8 inches on the ground. All right. So let's move over to brick and brick veneer. These are the common defects that we're going to see on these things, and we'll talk about them individually as well. All right. But mostly I want people to be able to tell the difference if the structure is a brick structure or if the brick we're seeing is just a brick veneer. Now, I've seen a lot of people get confused with something called thin brick and brick veneer. I want you to realize that thin brick is more of a tile, all right? And that actually gets mortared and glued onto the substrate, all right? Where brick veneer is a full-blown piece of brick, all right? But it's only one width thick, and we'll talk about that in a little bit. And it has no structural strength whatsoever, where a brick building is structural strength. Brick veneer is not. So let's hit these as we go through it. So how to identify and tell the difference between the two. First things first, let's talk about the bricks themselves, all right? And each row going horizontally, this is called a course, all right? So, and if the bricks are all laid in one pattern, then that pattern is the layer, or is what we're going to call a course. So this brick where my cursor is going across, that's laid out in a stretcher pattern. So anytime the brick is flat like this, that's a stretcher. If I take that same brick and I rotate it on its thin side, that's called a shiner. So I would like you to know the 6 different layouts of a brick. Stretcher, shiner, all right? The next one we're going to look at here is going to be our headers. That's these, and our roll locks. So now I'm taking my brick and I'm going this way. Roll lock, all right, so I got my stretcher right here. A roll lock is actually going to be perpendicular to that stretcher. It's going to be laid flat. But just like when I turn the stretcher on end and I call that a shiner, if I take that roll lock on end and I put it upright, that's now called a header. Typically, we're going to see the header courses over windows, under windows, used as sills, and so forth. All right. So roll lock, header. All right. The next one is going to be soldiers and sailors. So if I take that brick straight up and down, and a lot of times you'll also see this over windows, straight up and down is a soldier, and turning it flat side out, that's sailor. All right. So soldier, sailor. So again, stretcher, shiner, roll lock, header, soldier, sailor. All right. And let me come back to this one real quick. I like this picture here. So this is a true brick building. This is a 3-width building. All right. So this stack of bricks right here is 1 width. This stack of bricks right here is 1 width. This stack of brick as well is also 1 width. So when we're dealing with 3 widths, all right, that's for structure. And typically when we're dealing with residential, below grade, we're going to be 3 widths. Above grade will be 2 widths. Then we see our roll lock pattern. Notice what our roll lock does right here. It ties this width and this width. These are in stretcher. This is in stretcher. Same thing, these are all in stretcher, and then we tie them together. So the outside and the middle is tied together with this roll lock row, and then on the inside, we're tying them together, the inside and the middle, with this one. And if you go down a little bit further, you'll see the same thing, and you'll see that pattern keep going. Typically, it's every 7 courses. Sometimes you'll see it every 8 courses, sometimes 6. But 7 is a good average number. So if we start with this one, 1, 2, 3, 4, this one's 5. All right, so that's 5 courses. But like I said, typically it's going to be 7 as our magic number. And if we look at it from the side, we see this row right here is our header, and we said 5 before, so we go 1, 2, 3, 4, 5. Now we're going 6. Sometimes you gotta love it, but it is what it is. All right, and there's our other header row, and then if we go up another 6, we'll have another header row, and another 6, another header row. And these are tying those 2 widths together. And I shouldn't use the word row, I should use the word course. All right, so stretcher course, header course, stretcher course, header course, and then 1, 2, 3, 4, 5, 6 again. And we have another header course, and we'll find that going all the way down to the ground. All right. So that's going to be on typical solid masonry walls. All right. We also want to keep those walls from bowing out. So we usually have to tie those 2 walls together, and we're going to put steel rods going from the outside. The floor joists will keep them from coming in, but we need something to prevent them from going out. All right. Very rarely are we going to ever have weep holes. We're not going to have anything around windows. We may have arches or wood headers that come in there, but it's going to be rare. All right. Here they put the headers as an arch over the top of a window. All right. And you know, here we got a lot of water coming in too. You know, I know this slide is more designed to tell the difference between true brick and brick veneer, but when you start seeing multiple different colors of mortar and cracks coming back after the cracks have been repaired, that problem is still there, and something needs to be done. But again, this slide is designed to help you tell the difference between brick veneer and true brick. All right. I'm not so worried that you know the different types of mortar. Quite frankly, you're not. I don't know. I can't tell the difference, so I don't tend to worry about it. What I would like you to do is know this word for this stuff down here. This is called parging. Parging is supposed to be anywhere where water is going to be present. So at the bottom of chimneys inside, any brick that's below grade is supposed to have a parge coat on it. It's important because it's actually drawing the water out of the brick and helps keep the brick dry. All right. I do want you to know that term parge, and it's designed to fail. So usually it goes in about every 5 years, and it starts to crack and crumble, and at which time somebody needs to knock it loose and put a new parge coat on there. But you will find many times where it's neglected, and it's usually going to be the new owners that are going to come in here and put it on there, or they're just going to ignore it, and until it starts getting worse and worse and worse, and you got to rebuild the whole wall, nobody's really going to be taking action to it. All right. Now, brick veneer, behind this wall is going to be a wood frame wall. All right. And then we're going to have an air barrier attached to that wood frame wall. There's going to be an air gap, typically about 1/2 of an inch, maybe all the way up to an inch. And then we're going to put our 1 width of brick where we're going to stack this veneer wall on top of the foundation, and that's what we're going to look at. This has no structural support whatsoever. All right. Notice over the windows, we don't have any arches or gaps or anything. Typically, they're going to put a piece of angle iron up there. So you're going to see a steel lintel. Roll locks are nice. These are still supposed to be at 612, but it's all for decoration. You don't have to have it there. We do know that water is going to be getting between the brick and the wall, so because of which we need to have gaps on there to let that moisture out, let air get in there, let everything evaporate and dry out. Sometimes you'll see little ropes coming out of there, and sometimes you'll actually see holes. I like it when they put the weep wicks above windows as well, just because those are areas that are going to collect water and we want to let that get out, plain and simple. Weep holes, they're going to be about every 2 to 3 feet. So the bricks laid in the stretcher course, as we're looking at down there, are typically going to be 8 inches with the mortar joints and everything. So if you go every 3 bricks, that's about every 2 feet. All right. I wouldn't go much more than 4 bricks. All right, that would get you up to 32 inches and such. This is a side view of the same thing, so you can see our sill plate over here, and then we got our rim joists along with our floor joists, our plywood decking here, our sole plate and our stud going up, and our sheathing up underneath there. Now, the sheathing doesn't have to be plywood. All right, we are going to have some plywood in there just to give us some shear protection. But then we put our air barrier, and then we get a moisture barrier down low, because this is where it's all going to collect. That runs underneath the bottom layer of brick, and that's supposed to be showing. That's supposed to be showing on the outside. Now, a lot of people will delete that. Oh. All right, let's go back. Sorry about that. I dropped my little controller. I can't move it now. All right. So going back underneath here again, we're going to see where that moisture barrier. Sometimes people actually rip it down under here so it's not visible, so you can't always tell. But it's the weep holes or weep wicks that are going to be the most important thing on there. All right. The best way to do this, in my 2 cents, is to create a brick ledge. So when they pour the foundation, many times they're going to use a styrofoam block so that this does not fill in with concrete. And then we create that shelf, or the brick shelf on there. And then they'll bust away the concrete and dig it out of there. And that way we can go ahead and put our brick resting on the foundation so we can support all that weight. What's nice about doing this is that we got this whole area right in here for moisture to build up and then cause it to drain out before it's going to force its way over the top of the foundation and come inside. You don't have to do things this way, but it is the best practice. All right. You can go ahead and put on there a put on angle iron and support it. Now, in this case, the angle iron is sticking out quite a bit, so I think that's a little bit problematic in its own way. But, it is what it is. So, and that's just another view of the angle iron. Everything's bolted into the concrete. It's kind of weird. I never really noticed this cracking in the foundation before. You gotta start questioning things when you see stuff like that. At least make our clients aware of stuff. So, all right, cutaway brick details. They're going to end up having these metal straps that get mortared into the brick, and then it either gets screwed or nailed into the studs through the sheathing on here. And again, we want to have some sort of a moisture barrier on the outside, just because we know water is going to be accumulating there. I don't know any way that you can actually tell how many wall ties that they have. I guess I more or less want you to know that they should be there. All right. So again, we're looking at our flashing that goes through and underneath the brick. We want to make sure we got our weep holes there and our foundation with the brick shelf. All right. And here they're just another diagram showing water is expected to get in there, and we want to be able to let the water get in and get out. All right. Flashing weep holes, we talked about it, not less than 3/16 immediately above the flashing. All right, this is a picture. You can see the actual flashing or moisture barrier that's on there. Here they decide to leave gaps in between the bricks, so those are weep holes. You know, it's totally acceptable. And these are weep wicks. If we got water that comes out of that, again, totally acceptable. I've never seen where brick veneer was coming loose and pulling away from the building like this before. You know what? That's not true. I just saw this, not this drastic where it's the full wall, but I just saw this last week, actually. One of the last houses we looked at before the end of the year was in Evanston. And what we had was a window and then a sill plate underneath the window and then brick underneath that. Water was getting behind the sill plate and it was getting trapped inside the brick in between the wall and the brick veneer. And that water was filling up, and in the wintertime it was freezing, and when it was causing it to freeze, it was pushing that brick away. You know, now it didn't cause the whole thing, but it definitely pulled it away. And really, I had no cure. I don't know if they'll ever be able to get that pushed back in there or not. And, you know, so if they're going to go ahead and pursue that house, you know, they're going to, well, first we got to stop the water from getting in there. Secondly, they're going to probably end up rebuilding that wall. So it does happen. I forgot about that one. Steel lintels, they do rust. I do want you to understand that when steel rusts, it expands. And what happens here, if it starts to expand, you're going to start seeing cracking at first going off the sides. What that really is the steel lintels pushing things out and coming out. This was actually a complaint that we had from a buyer about a year ago, and we called it out. All right, so the lintels were rusting. They did kick out and crack the mortar. They lifted as well right over the windows, but the lintels were still in good shape. They were still doing what they were supposed to do, and that's holding the brick that's up above them. So in our opinion, we didn't think they needed to be replaced, not yet. All right. But we should do what we can to prevent it and extend the lifespan of them. So keeping them painted, you know, if we can get some weep holes or weep wicks in there, drain that water out, you know, that would be the best avenue. But realize it is going to get worse and it is going to fail over time. Now, whether they didn't trust our opinion on that or whatever, after they moved in, they contacted a mason, and the mason who specializes in doing these lintel replacements, they charge about $2,000 for each window to go ahead and replace these things. And of course, he's telling them that they needed all to be replaced. All right. I've been, you know, running into a lot of contractors that, you know, in my opinion, it's just they're selling you a cure that you don't need. So we've been kind of switching our wording around, and especially in our agreement, and letting people know, hey, this is our opinion. You know, if you don't want to trust us and you want to get an opinion from somebody else, you're free to do so. All right. But, you know, and there will be other people that disagree with us. There will be people that will want to tell you that you should pull these bricks out and pull that steel out, put new ones in there because we already had a cracking. But as far as we're concerned, it doesn't affect the operation of the window. It's still supporting the bricks that are up above it. Yes, it has started to deteriorate, but just because something started to deteriorate doesn't mean it calls for a replacement. Again, that's my opinion on sort of things. And they chose not to get it repaired, and that's, again, their choice. They could have also spent the $30,000, but I think they would have spent it easily if we would have said, oh, yeah, we should have told you to get it replaced. And then that contractor would have said, yeah, I'll do it for $30,000. I'm sure he would have. All right. So as far as I'm concerned, these are typical. All right. But I want to give you a heads up that you are going to find contractors out there that tell you have to replace these now. I just disagree with them. All right. However, this drawing here on the right-hand side, And when we get into structures, we're going to talk about reading cracks. But that lintel only supports the bricks that are above it in this triangle pattern. All right, doesn't go straight up. It's only in an immediate triangle, and that's it. When this steel lintel fails and it's gone, and now it's beginning to sag, that's when you're going to start seeing step cracking above here. That's telling me that the brick below that. So when I see these cracks on an angle, everything, think of it like an umbrella, and everything underneath it is settling. All right, and the crack goes down, and if it goes down and to the right, we go to the right side of that crack. That's the last point of support, is right there. Everything here is dropping, or that's being pushed up, one of the two. So here, if we look on the left-hand side, we can see our cracks are going outwards. And that's going to be telling me that I probably got water in there, and it's freezing, and it's lifting up on those bricks. And I'm going to get, and that's where it's going to be failing. So that's heaving on the left, where I have settling on the right. And this is what we normally see. The lintels rust. They get bigger. They'll lift the brick up. They'll push the mortar out. Typically, they'll go 3 to 6 inches to the left and right of the window. Sometimes I'll see multiple repairs there, But my big thing that I'm looking for is that triangle over the top of the window. And, letting my clients know how long it's going to last, there's really no way. But typically, a steel lintel like that, even if it's getting wet, you should be able to get 50 years out of that. But these older buildings, you just don't know when it was installed or how old it is and so forth. So this one was kind of a no-brainer, made my life a little bit easy. You can see they took a concrete saw and they cut out the square for the window, and nobody put any support at all into this thing. So I just have the bricks sitting up there. Now, this was cut. This is relatively new. So I did not have any sort of settlement cracks or anything else in the bricks. But I definitely took a picture of it and let my client know about it. And, you just don't know. Sometimes you might get lucky and it'll last for a long time, but I can't count on that. As far as I'm concerned, I would tell my client, we want to get a piece of angle iron in there. This is one of those situations I would get hold of a mason and I would pull the bricks out. I would not wait for this thing to settle and crack. I think more so when I get to something where I have that lintel there, I think the process is going to be much slower and I'm going to have an easier time. And this is all my imagination, just the way my brain is thinking. But when I'm looking at this one here where I got nothing, once that decides to move, what's going to stop it? Nothing. And at that point in time, I think it could be catastrophic. Now, it should only be that triangle above it, but still, what are you going to do if you got a big hole above your window where the bricks start falling and falling down on top of people?